Good day, everyone. We are the Group 1, and meet our team. We have yours truly, Eliza Arabis, Raka J. Konag, Vanessa Diaz, Jamaica Marie Duran, Joanna K. Lim, Angelica Bella Macasero, and Jezreel Maitaneo. And our topic is all about climate temperature. Temperature is a measure of the amount of heat in the atmosphere, while climate refers to the long-term patterns and trends of weather in a particular region. The temperature of any point in the universe is generally very low, exceptions to where nuclear fusion produces enough energy for high temperature, like the stars, and other places that are islands of high temperature due to the heat-trapping gases such as the carbon dioxide. Right after the Big Bang, it says that the universe had a temperature of about 1032 Kelvin, that is equivalent to 758.85 degrees Celsius. As the universe expanded, it eventually cooled to about 3 kelvins, that is equivalent to negative 270.15 degrees Celsius, which it is today. Temperate climates of the Earth are characterized by relatively moderate mean annual temperature, with average monthly temperatures of above 10 degrees Celsius in their warmest month, that is during July, August, September, and October, wherein each brought a high record of average global temperature and above negative 3 degrees Celsius in their colder month, that is during winter or rainy season.
Now let's talk about the classification of climates. In 1948, American climatologist Charles Thornthwaite developed a climate classification system that scientists still use today. Thornthwaite's system relies on a region's water budget and potential evapotranspiration. The major classifications in Thornthwaite's system climate classification are microthermal, mesothermal, and megathermal. Microthermal climates are characterized by cold winters and low potential evapotranspiration. Most geographers apply the term exclusively to the northern latitudes of North America, Europe, and Asia. A microthermal climate may include the temperature climate of Boston, Massachusetts, and the coniferous forests of southern Scandinavia and the boreal ecosystem of northern Siberia. Mesothermal regions have moderate climates, meaning they are not cold enough and they are not warm enough to support other all living things. Mesothermal climates include the Mediterranean basin, most of the coastal Australia, and the Pampas region of South America. Megathermal climates are hot and humid. These regions have a high moisture index and support rich vegetation all year. Megathermal climates include the Amazon basin, many islands in Southeast Asia such as New Guinea and the Philippines, and the Congo basin in Africa. The most popular system of classifying climates was proposed in 1990s by Russian-German scientist Vladimir Köppen. Köppen observed that the type of vegetation in a region depended largely on a climate. According to the Köppen climate classification system, there are 5 climate groups, namely tropical, dry, mild, continental, and polar. These climate groups are further divided into climate types, which can be seen in the next slides. First, we have the tropical climates. There are 3 climate types in the tropical group, which is the tropical wet, tropical monsoon, and tropical wet and dry. Let's now have the tropical wet. These equatorial regions have the most predictable weather on Earth with warm temperatures and regular rainfall. Annual rainfall exceeds 150 centimeters or 59 inches, and the temperature varies more during a day than it does over a year. The coolest temperatures is about 20 degree to 23 degrees Celsius, or about 68 degree to 73 degree Fahrenheit, occurs just before dawn. Afternoon temperatures usually reach 30 degree to 33 degrees Celsius, or 86 degree to 91 degree Fahrenheit. Rainforests experience very little seasonal change, meaning average monthly temperatures remain fairly constant throughout the year. Tropical wet climates exist in a band extending about 10 degrees of latitude on either side of the equator, and this part of the globe is always under the influence of the intertropical convergence zone, and it moves north during summer in the northern hemisphere and south during the northern winter. The U.S. state of Hawaii, Kuala Lumpur, Malaysia, and Belém, Brazil are examples of areas with tropical wet climates. Next is the tropical monsoon. Tropical monsoon climates are most found in southern Asia and West Africa. A monsoon is a wind system that reverses its direction every 6 months. People living in these regions depend on the seasonal rains to bring water to their crops, and India and Bangladesh are famous for their monsoon climate patterns. Third in line is the tropical wet and dry savanna. Tropical wet and dry climates sit just outside the ITCZ near the equator. They have 3 seasons. One season is cool and dry when the warm, moist ITCZ is in the opposite hemisphere. Another season is hot and dry as the ITCZ approaches, and the last season is hot and wet as the ITCZ arrives and the region experiences months as a tropical wet climate. Havana, Cuba, Calcutta, India, and Africa's vast Serengeti Plain are in the wet and dry tropics. Let's now have the dry climates. Regions lying within the dry climate group occur when precipitation is low. There are two dry climate types, arid and semi-arid. The hottest spots in the world are in arid climates. The temperature in the arid Death Valley National Park, California, U.S. reached 56.7 degrees Celsius or 134 degrees Fahrenheit on July 10, 1913, which was the highest temperature ever recorded. Although rainfall is limited in all dry climates, there are a few parts of the world where it never rains. One of the driest places on earth is the Atacama Desert of Chile on the west coast of South America. Stretches of the Atacama may have never received rain in recorded history. Semi-arid regions such as the Australian outback usually receive between 25 and 50 centimeters or 10 to 20 inches of rainfall every year. Denver, Colorado, just east of the U.S. section of the Rocky Mountains, has this type of dry climate known as a rain shadow. Regions with mild and continental climates are also called temperate regions. In these parts of the world, climates is influenced mostly by latitude and a region's position on the continent. Mediterranean climates have warm summers and short, mild, rainy winters. Mediterranean climates are found on the west coast of continents between 30 and 40 latitude and along the shores of the Mediterranean Sea. Mediterranean summers feature clear skies, cool nights, and little rain. Next, we have the humid subtropical. Humid subtropical climates are usually found on the eastern sides of continents in cities such as Savannah, Georgia in the US, Shanghai, China, and Sydney, Australia. Summers are hot and humid. Winter can be severely cold. Precipitation is spread evenly through the year and totals 76 to 165 centimeters or 30 to 65 inches. Hurricanes and other violent storms are common in these regions. For the third type, we have the marine west coast. Weather on both sides of a continent generally becomes cooler as latitude increases. The marine west coast climate, a type of a mild climate typical of cities such as Seattle, Washington in the US, and Wellington, New Zealand, has a longer, cooler winter than the Mediterranean climate. Drizzle falls about two-thirds of winter days, and temperatures average about 5 degrees Celsius or 41 degrees Fahrenheit. Areas with continental climates have colder winters, longer lasting snow, and shorter growing seasons. They are the transition zones between mild and polar climates. Now we have the warm summer. Warm summer climate regions often have wet summer seasons similar to monsoon climates. For this reason, this climate type is also called humid continental. Most of the Eastern Europe, including Romania and Georgia, has warm summer climates. Second, we have the cool summer. Cool summer climates have winters with low temperatures and snow. Cold winds sweeping in from the Arctic dominate winter weather. People living in these climates have grown accustomed to the harsh weather, but those unprepared for such cold may suffer. Many of French Emperor Napoleon Bonaparte's soldiers, for example, were used to the mild Mediterranean climates of France. Thousands died in bitter cold as they retreated from Russia's cool summer climate in the winter of 1812. The third type we have the subarctic. North of regions with cool summer climates are regions with subarctic climates. These regions, including northern Scandinavia and Siberia, experience very long, cold winters with little precipitation. Subarctic climates are also called boreal climates or taiga. Let's now have the polar climates. The two polar climate types, tundra and ice cap, lie within the Arctic and Antarctic circles near the North and South poles. In tundra climates, summers are short, but plants and animals are plentiful. Temperatures can average as high as 10 degrees Celsius or 50 degrees Fahrenheit in July. Few organisms survive in the ice cap climate of the Arctic and Antarctic. Temperatures rarely rises above freezing even in summer. The ever-present ice helps keep the weather cold by reflecting most of the sun's energy back into the atmosphere. Skies are mostly clear and precipitation is low. In fact, Antarctica, covered by an ice cap 1.6 kilometers or 1 mile thick, is one of the largest, driest deserts on Earth. Many geographers and climatologists have modified the open classification system over the years, including geographer Glenn Triwartha, who added a category of climate classification system for high elevation climates. So there are two high elevation climate types, namely upland and highland. Both highland and upland climates are marked by very different temperatures and levels of precipitation. Climbing a lofty mountain or reaching a plateau can be like moving toward the poles, and on some mountains, such as Mount Kilimanjaro, Tanzania, the climate is tropical at the base and polar at the summit. Often, high elevation climate differs from one side of the mountain to the other.
The key factors influencing climate temperature. Climate has influenced the development of cultures and civilizations.
People everywhere have adapted in various ways to the climates in which they live, like clothing. Yes, clothing is influenced by climate. For icy climate countries, they wear warm and durable clothes like winter clothes such as coats, jackets, gloves, and many more. Meanwhile, for the countries with humid climate, they wear lightweight clothes like shirts and shorts made of breathable fabrics. Climate also influences how civilizations construct housing. Some people in southern North America built apartments into tall cliffs. The sheltered, shady area kept residents cool in the hot, dry desert climate. Next is the yurt, or a type of mobile home. It is a portable, circular dwelling made of a lattice of flexible poles and covered in felt or other fabric. Yurts protect residents from fierce winds. The development of agriculture was also very dependent on climate. Countries like India, where the climate was mild, communities could grow crops every season and experiment with different types of crops, livestock, and farming techniques. Today, farmers are still in tune with the climate. They plant certain crops according to the expected amount of rainfall and the length of the growing season. When the weather does not follow the typical climate pattern, it can mean hard times for farmers and higher food costs for consumers.
Impacts of climate on ecosystems. Species distribution. Temperature plays a critical role in determining where species can thrive. Changes in temperature, whether due to climate change or other factors, lead to shifts in the geographical distribution of species. This, in turn, has a direct impact on the composition of ecosystems, as certain species may thrive in new areas while others may face challenges in adapting. Phenological changes. Temperature influences the timing of crucial biological events such as flowering, fruiting, migration, and hibernation. As temperature changes, these events may be advanced or delayed, disrupting the synchronizations between species interactions. This can have cascading effects on the overall dynamics of ecosystems. Changes in soil processes. Temperature influences soil processes including nutrient cycling and decomposition. Warmer temperatures can accelerate these processes, affecting the availability of nutrients in the soil. This, in turn, can impact plant growth and the overall health of terrestrial ecosystems. Increased fire frequency. Warmer temperatures contribute to drier conditions, increasing the frequency and intensity of wildfires. Wildfires can have profound impacts on terrestrial ecosystems, leading to habitat loss, changes in vegetation, and disruption to ecological processes. Understanding the link between temperature and fire frequency is essential for managing and mitigating these impacts. Shifts in water temperature and aquatic ecosystems. Changes in air temperature can influence water temperature in rivers, lakes, and oceans. This, in turn, impact aquatic ecosystems, affecting the distribution, behavior, and reproduction of aquatic species. These changes have implications for fisheries, water quality, and overall aquatic ecosystems health. Glacial and permafrost melting. Rising temperatures contribute to the melting of glaciers and permafrost in polar and mountainous regions. These meltings have far-reaching consequences, including habitat loss, altered water availability, and changes in ecosystems adapted to cold conditions. Understanding these changes is crucial for predicting future impacts on biodiversity and ecosystems.
Evidences of climate change. There is a substantial body of scientific evidence supporting the existence of climate change, particularly in the form of rising temperatures. Rising temperature readings. The record shows a rising trend in global average surface temperatures back to the mid 19th century shows a clear upward trend in global temperatures. This warming trend is supported by data from various meteorological organizations, including NASA and the National Oceanic and Atmospheric Administration, or the NOAA. Next, we have the proxy data. Scientists use what is known as proxy data to reconstruct past climate conditions. Scientists use proxy indicators like tree rings, ice cores, and sediment to reconstruct past climate conditions. These proxy data are preserved physical characteristics of the environment that can stand in for direct measurements. This indicator consistently shows that recent decades are warmer than any comparable period in the past several centuries. Glacier retreat. Glaciers around the world have been retreating over the last century. The shrinking of glaciers is a visible and measurable indicator of a warming climate. Sea level rise. Melting of ice sheets and glaciers, combined with the thermal expansion of seawater as the oceans warm, is causing sea level to rise. Seawater is beginning to move onto low-lying land, contaminating coastal freshwater sources and gradually submerging coastal facilities and barrier islands. Ocean heat content. The total amount of heat stored by the ocean is called ocean heat content, and measurements of water temperature reflects the amount of heat in the water at a particular time and location. Arctic sea ice decline. Sea ice in the Arctic region has declined in recent decades in area and volume due to climate change. The Arctic is warming at a rate approximately twice as fast as the global average. It has been melting more in summer than it refreezes in winter. Extreme weather events. As the Earth experiences climate change, it is impacting extreme weather events globally. Although specific weather occurrences cannot be directly assigned to climate change, there is evidence indicating an elevated frequency and intensity of certain extreme events, such as heat waves, hurricanes, and droughts, in a warming climate.
The beauty of industrial engineering is that it can improve, streamline, and make systems more sustainable. So, what does that mean and why is it important? Well, it essentially means that we can reduce waste, save energy, and decrease harmful emissions. We can also optimize processes for the efficient use of resources, reduce negative environmental impacts, and increase social responsibility. One essential step that aspiring industrial engineers must take to contribute to climate improvement is to have continuous learning and studying about how to promote sustainable practices throughout the supply chain, including sourcing materials responsibly, reducing waste, and optimizing transportation routes. This can minimize the carbon footprint associated with product manufacturing and distribution. Industrial engineers can also promote lean manufacturing principles to reduce waste, optimize resources, and improve energy efficiency. Techniques like 5S, value stream mapping, and Kaizen can be used to identify and eliminate waste in manufacturing processes. Industrial engineers also play a crucial role in implementing quality control and assurance processes to ensure that products are safe, reliable, and meet sustainability standards. Furthermore, they can also collaborate with relevant stakeholders, including government agencies, industry associations, and local communities to promote sustainable practices and advocate for policies that support climate improvement.
Recommendation strategies that can be applied for an effective improvement of our climate. First, we have invest in green technologies. One of the biggest benefits of investing in or switching to a green technology is the benefit to the environment. It helps to evaluate and adapt emerging technologies like carbon capture and storage, green hydrogen production, and sustainable waterways treatment. By applying green technologies, we can offset carbon emissions. It reduces emissions of carbon dioxide and other greenhouses in order to prevent climate change. By switching renewable technologies and other resources that cannot harm our environment. And lastly, it is important to promote environmental awareness, raising awareness among colleagues and your family, management about the urgency of climate change and the role of industry in finding solutions.
Industrial engineering isn't just beneficial to companies looking to improve their bottom line by cutting costs, nor it being a fancy name for optimization. It's a key driver in creating a more sustainable and resilient society for future generations. It's a field that has the potential to revolutionize the way we manufacture and operate our systems, and ultimately create a better and more sustainable society while driving growth and innovation.
Remember that small changes and continuous improvements can make a big difference. We have the special abilities and knowledge as an industrial engineers to significantly advance our field's progress and build a more sustainable future. When taking on the issue of climate change, exercise initiative, creativity, and perseverance. The actions you took may have a long lasting and a positive effect on our environment. Thank you.